tried to, but it's not letting me. Okay.
Okay, so next, you need to understand what some of these terms are. The thingamajig in the big bracket, this is called the dividend. This one is called the divisor, okay?
Okay.
This is called the quotient. And this is called the remainder. So what is this problem? Actually, this problem is 13 over 5, yeah?
Yeah.
You can rewrite this as 2 plus 3 over 5. In other words, dividend over divisor, you can write that as equals to quotient plus remainder over the divisor.
Okay. Okay.
What you could do is you can multiply both sides by 5 on the top one, then you would have 13 equals what? 10 or 5 times 2 plus 3, right?
Yeah.
So another way of writing the same thing is that dividend by itself is the divisor times the quotient, yeah, plus the remainder. So two different notations for this, okay? Now let's do something a little bit more complicated. Alrighty, now we have a cubic function that's being divided by a linear function. So if the divisor, right, the guy you're dividing by is linear, there's two different ways to do this. Let's do the first way, the traditional way. This is called a long division.
Okay.
So I'm going to throw this guy in here, okay, x minus 3. Now, how do you do this long division? Step 1, check if everything is in descending order.
Okay.
So it's x3, x2, x, and 1, right? So that's fine. Let's say there was no 7x. It was just this function. Then you'd add an arbitrary 0x into the question. And you'd have a 0x. It always needs to be in descending order. Otherwise, it's not going to work out. Okay? Step number 1. We need to multiply x with something, yeah? So that this x becomes 3x cubed. So x times something is 3x cubed. What would that be? 3x squared.
Okay. Yeah.
Okay, and why did we do this? Because this term is going to cancel out completely here. X times 3x squared is 3x cubed, yeah?
Yeah.
And then again, don't forget about this. We don't look at this when we're trying to put the quotient, but that's still part of the equation here. So negative 3 times 3x squared is minus 9x squared, yeah?
Yeah.
Now, we always in this, we subtract. 3x3 and this cancels out. And then negative 5x squared plus 9x squared. Notice this becomes a plus.
Yeah.
So that's going to give us a 4x squared. And once you cancel something out, you're allowed to bring the next term down.
Okay.
Now the same thing. What do we need to multiply x by so that we get 4x squared?
X.
4x, yeah?
Yeah. Yeah.
Now we do the same thing. X times 4x is 4x squared. And minus 3 times 4x is minus 12x. And we subtract it, this cancels out. Negative 7 plus 12 is 5x. And once you cancel something, you can bring the other guy down. And finally, x times 5, yeah, plus 5 is 5x. So you have 5x minus 15. Again, we subtract it, the remainder is 14. And they want the quotient here. Quotient is this guy. And that's the answer.
So you don't do anything to the remainder?
No, because if x does not go into 14 anymore, so you just stop there.
Okay.
That makes sense?
Yeah.
Can you move a little bit closer to the mic? Are you using the laptop microphone?
Yeah.
Yeah, it's a little hard to hear you.
Okay, I'll move closer.
All right. Now this is a long division way, okay?
Okay.
Which I don't really like. There's an easier way to do this, but for that one, you can only do it if the divisor is linear. You see, this is linear. It can be any linear, like 3 minus 8x doesn't matter, but it has to be linear. Okay. So here, if x minus 3, right? So what will be the x-intercept of this linear function?
+3.
Yeah, +3. So this system is called synthetic division. Okay, I like this. This one is more efficient. It's easier as well. It's faster and it's easier. So whatever the x-intercept is, that's gonna be our divisor. Okay.
Okay.
So that's gonna be 3. For example, here, if it was 5x minus 2, the x-intercept would be 2/5. This is called the k-value.
Yeah.
Okay, this is called the k-value. Now in synthetic division, you're not really interested in the powers. You're just interested in the coefficients. So here we have 3, -5, -7, and -1. Okay.
Okay.
Just like before, if there's something missing, let's say the 7, this term did not exist, then you'd put an arbitrary 0 here.
Okay.
And you do the same thing in long division. Now, how does synthetic division work? It works something like this. The first guy drops down as it is. So this 3 here, it's just a coincidence. There's a 3 on the outside, nothing to do with this. This 3 is from here. It drops down as it is, okay? And now you multiply this 3 with this 3. 3 times 3 is 9, and that goes up here.
Okay.
Okay. The thing with synthetic division is that instead of subtracting, you add.
Okay.
So -5 plus 9 is what? +4. Yeah.
Yeah.
Then again, you multiply this 4 times 3. You're always going to be multiplying with the divisor. That's going to be 12. Yeah.
Yeah.
And then -7 plus 12, always add here. It's going to be 5. And 5 times 3 is 15. And then we add this, you get a 14. Okay.
Yeah.
The last term here is a remainder, just like we had here.
Oh, okay.
And this is our quotient, but the powers here is always 1 below what you started off with. See, we start off with an x cubed. That means this guy is x squared. So our quotient is 3x squared plus 4x plus 5. And there we go. That's the answer. Just like we had up here.
Yeah, this one is much faster.
This one's much faster, but this one doesn't always work though, because it only works when the divisor is linear.
But the long division works if it's anything?
Yeah, the long division is bulletproof. It always works. It's like the quadratic formula.
Okay.
Like this one is a man method, right? The 2 numbers that multiply to something. It's gonna work. It's quicker, but this one's like the quadratic formula. It's gonna work regardless.
Okay.
Yeah, see here? It says determine the remainder of this, right?
Yeah.
Can we use synthetic here?
No.
No, we cannot, right? We cannot
Because
use
the
divisor.
is not linear.
Exactly. So what we're gonna do is we're gonna set this up. So again, it has to be in descending order, biggest to smallest, the degrees, okay? So x2 plus 2x plus 1, nothing missing there, that's good. Let's see if something's missing here. Again, the biggest one is x4, then you have minus 2x3, then you have plus 5x plus 3. Is something missing here?
Yeah, for an x squared, but
Exactly.
you could add a 0.
So it's x squared is missing, but we're gonna add an arbitrary plus 0x squared, and then we have the plus 5x, and then we have plus 3. Okay?
Yeah.
Once you have set this up, now we gotta look for this. X squared times something is x4. What is that?
X squared.
Yeah, so that's our quotient up there. And now you gotta multiply x squared with everything. So x squared times x squared is x4. 2x plus x squared is plus 2x3. Plus 1 times x squared is just x squared, right?
Yeah.
And then we subtract. So x4 minus x4 gone. This minus this becomes minus 4x3. And 0x squared minus x squared becomes minus x squared. Once you kill something, you're allowed to bring something else down.
Okay.
So what's the next entry up here in the quotient? We need a negative 4x3, we have x squared.
We need negative 4x.
Yeah, yes, negative 4x. So that's gonna give us a negative 4x3. And then 2x times negative 4x is minus 8x squared. Plus 1 times this is minus 4x. And again, we subtract this. So this cancels out. This is going to become negative x plus 8. So that's going to become a 7x squared. This becomes a 5 plus 4 plus 9x. We killed something. We're allowed to bring the next guy down. What's the next entry up here?
7.
Yeah, so plus 7. So you have a 7x squared plus 14x plus 7. Yeah.
Yeah.
So subtract, this disappears, and then 9x minus 14x is minus 5x. 3 minus 7 is minus 4, and that's our remainder, and that's the answer.
Okay.
Is that good?
Yeah.
So they're asking us for the remainder, right? So you can write this as this. Again, the notation is kind of tricky. Always remember this, right? Something like this. 11 over 5 is 2 plus 1 over 5. Okay.
Okay.
So they're asking us for the remainder, that's this, but in terms of what is this equals to? This will be equals to the quotient, x squared minus 4x plus 7, okay? Like here.
Yeah.
Plus the remainder minus 5x minus 4 all over the divisor, 1 plus 2x plus x squared.
Okay.
Is that good?
Yeah.
Yeah, that's pretty much it for like long division and stuff. Once you know how to do one of them, like you basically know how to do all of them.
Okay.
Okay.
I think there's like 2 different sections for this.
Yeah. So there's some other things here that you should know. And eventually you'll be graphing quartic, and it's just gonna give you this equation, right? And they're gonna ask you to graph it. So how do you go about graphing it? You need to do long division to find its factors, or synthetic division to find its factors. So here, let's do this. This is gonna be a new idea. So determine whether this is a factor of this, okay?
Okay.
Let's call this f of x.
Okay.
All right, here's the technical term for this, okay? A technical theorem. This is called a factor theorem. We could do long division, and we could see whether the remainder is 0. Something is a factor, right? 5 is a factor of 100 because the remainder is 0. 2 is a factor of 10 because the remainder is 0. As long as the remainder is 0, it's a factor of something. Same thing applies to polynomials. So the factor theorem. If you have some divisor f of x, yeah, and you're dividing it by a divisor x minus k, okay?
Okay.
If the remainder is 0, then x minus k is a factor of f of x.
Okay.
Okay, you understand this?
Yeah, that makes sense.
So this divided by this, as long as the remainder is 0, it's a factor. So we can just use synthetic here really quickly. So what will be the k value?
The -2.
Yeah, -2, and again, the biggest to smallest. 1 minus 2, 0, 13 minus 6. 0 for the missing x squared, right? Again, look at how this works. This comes down as it is. And then what do we do? If you remember.
Then you multiply it by the -2, and then you add it to put it under the next term.
Yes, so you multiply this, you get a -2, you add them up, you get -4. This times this is 8, you add them up, you get an 8. 8 times -2 is -16. Add them up, you get -3. -3 times -2 is +6. And if you add them up, you get a 0. So what's the remainder?
The 0, so it is a factor.
It is a factor, right? So
Yeah.
what does that say? Again, f of x divided by x minus a. This is a factor of this if the remainder is 0. That's the remainder theorem. Or sorry, that's the factor theorem. But there's an easier way to check what the remainder is. Now let's move on to the other part, which is called the remainder theorem. Very similar to factor theorem. If you have something, f of x, you're dividing this with some, it's always going to be linear divisors in these cases. X plus 2, or sorry, x minus k. If you're dividing it by something, x minus k, okay? Then the remainder is f of k.
Okay.
Okay, now how does this work? So we're dividing this by x minus k, right? So what's k? -2, yeah?
Yeah.
So if this is f of x, we're just gonna find f of -2, and it turns out that's gonna give us a 0. So f of -2 is gonna be 13 times -2 minus 2 times -2 cubed plus -2 times 4 minus 6, yeah?
Yeah.
It's minus 26 plus 8 times 2 is 16 plus 16 minus 6. So that's -32 plus 32, that's 0. There we go. So you don't even need to do long division in any way. You can just do this. That'll give you the remainder. Yeah.
Yes, like the remainder theorem only works if the thing you're trying to see if it's a factor is linear, right?
Yes, and it'll always be linear in these types of questions. It'll only
Oh,
be non-linear if they ask you like a long division question just to see it.
okay.
Yeah.
Okay.
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 So
Yeah.
use this, right? This is very quick. You don't even have to do long division.
Okay.
Factor theorem, remainder theorem. And once you find the remainder 0, that means it's a factor. And then you can do and then you can play around with that. That's actually how you'd factor this. Let me show you actually. The question would be like factor this, nothing else. Okay.
Yeah.
The question will be simply they're going to throw that at you and be like factor this, graph it, or whatever, a question like that.
Mm-hmm.
So how do you approach that? Step 1, you look at the y-intercept. It's 6, yeah?
Mm-hmm.
So what are factors of 6?
1 and 6, 3 and 2.
Yes, so there's a bunch of them, right?
Yeah.
So let's say this is f of x. So the factors of 6 is plus minus 1. Again, the negative sign doesn't really matter. Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Yeah?
Mm-hmm.
And
Yeah.
then what you do is they won't give you this. They just gave it to you here just to show you. They won't give this to you. Then you want to plug all of these in and see which one of them gives you a 0. So if you plug f of 1, would that be a 0? No, that's not a 0. So that's not a factor. X minus 1 is not a factor. F of negative 1, not a 0 either. F of negative 2 gives us a 0, right? That
Okay.
means
Yeah.
x plus 2 is a factor. And once you have
Okay.
this, once you figure this out, you want to do long division, okay?
Okay.
If you do long division, x4 over x, you'll get an x cubed. The quotient will be x cubed, right?
Mm-hmm.
And then let's say the quotient is something like 3x3 plus 2x plus 9. Let's say this is the quotient. And this, we can call this g of x. Then again, you want to do the exact same as you did here, because the only way to drop down from a higher degree to, you need to get to quadratic. From quadratic, you can use either the man method or the quadratic formula. The goal is to drop down to quadratic, okay?
Okay.
So if they give you an x4, divide it by a linear to get to x3. And again, you want to check the factors of 9 is plus minus 1, plus minus 9. Then you want to check which one of them gives you a 0. And then you want to do a long division with that. And then finally you get to quadratic.
So is this to graph it or is this for factoring it?
Yeah, to graph it, you need to factor it to find the x-intercepts.
Oh, okay.
So it's to both.
Okay. Okay.
Here, let's see if they have a question here. Alrighty, here's a question. It says 2x plus 3 is a factor of this, and they want us to determine all the zeros and to sketch a graph of the polynomial. So what will be the first step?
We could do the remainder theorem.
We don't need to do the remainder theorem because we know it's going to be 0, right? See, it already says it's a factor. Yeah.
Oh, yeah. Okay.
So the remainder theorem, they've already done it for us. So
Then
here
we
what
can use the y-intercept to find the other factors.
we could, but that's gonna take some time, right? Because you have plus minus 1, plus minus 3, plus minus 5, plus minus 15. The best way to do it would be to just divide this by this and you get a quadratic.
Okay.
And quadratic is much more easier to factor than cubic or quartic or quintic. So straight up here, what we're gonna do is we're gonna do this divided by this. And that will give us a quadratic quotient, okay? And again, if this is linear, always use the synthetic. That's minus 1.5, right?
Yeah. Yeah.
The x-intercept there is minus 1.5. You could do 3 over 2, but I like my decimals because I can do it in my head. So it's x3, x2, x, and then minus 15. Nothing missing? Nothing missing, good. 6 drops down, yeah?
Yeah.
6 times minus 1.5 is minus 9. You add them up, you get minus 4. Minus 4 times minus 1.5, I think is 6, yeah? This is gonna add up to negative 10. Negative 10 times this is positive 15, 0.
Okay.
So what's the quotient here?
4x squared minus 4x minus 10.
Yeah, so 6x squared minus 4x minus 10, right?
Yeah.
We can take out a 2 from all of them. So 2 take out, you get 3x squared minus 2x minus 5, right?
Yeah.
And now we're just gonna use the man. Do you know the man method? Like that's what I like to call it. Maybe I think we did this together. We're looking for two numbers that multiplies to what?
To the last number and adds up to the middle number.
Not to the last number. It multiplies to a times c.
Okay.
So multiplies to negative 15 and adds up to the middle number. That's right. That's the b value, right? Ax squared plus bx plus c. That's negative 2. So what are our two numbers?
3 and 5.
Yeah, 3 and negative 5. Okay.
Yeah.
So what we're going to do is we're going to change the minus 2x in the middle into 3x squared plus 3x minus 5. You know how to do this, right? We're just factoring a quadratic. Yeah, and then from here, it's simple. You just take out a 3x from the first two. You're left with x plus 1, and then take out a minus 5. You're left with x plus 1. And then therefore, the quadratic factors out to 2 times 3x minus 5 times x plus 1. Okay?
Okay.
This is a quadratic. And remember, we need a cubic, so we just need to multiply this by 2x plus 3, the first factor. And this is the factored form of f of x.
Okay.
All right, you see that?
Why did you add the 2x plus 3?
Because this is just the quotient, right? So I need to multiply the quotient with the divisor to get f of x.
Oh, okay. Okay.
So I multiplied it there. And here we can graph this. This is a cubic function. We know it's a positive cubic, so it's gonna start here, right? It's gonna end up there. The y-intercept here is minus 15. And what are our zeros? Our zeros is negative 1.5 from this one, negative 1 from this one, right?
Yeah.
And then 5 over 3 is like 1.66, 1.66 there.
Okay.
And now we just connect the dots. We need to go there, 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 and we need to end up there. So it's probably going to look something like this. And there you go. This is the graph of this.
Okay.
That makes sense?
Yeah, I'm just a little confused from like how you went like after you got the factor to the new one. Like after you factor the quadratic and then.
Oh, you just so once we factor the quadratic, this is the quadratic in its factored form, yeah?
Yeah, yeah,
What was this? The quadratic is our quotient, right?
yeah.
Quadratic is our quotient. Just think about this. 5 times 4 is 20, right?
Yeah.
So how can we rewrite 20? 20 is equals to 5 times 4. So that's what I did here. So f of x is our divisor, or sorry, is our dividend, right?
Yeah.
So f of x is our dividend. That's 20. So f of x is equals to the divisor, right? 5. So 2x plus 3 times the quotient, 2 and then 3x minus 5 times x plus 1. Quotient times the divisor is a dividend.
Okay. So where did the 2x plus 3 come from? Like was that from the?
Oh, yeah, it's from here. It's from here.
Oh. Okay.
This is the 5. This is the 5.
Yeah. Okay. That makes sense.
Okay, and that's how you graph, and that's how you factor and graph a cubic or a quartic or a quintic. It's annoying actually. If they give you a quintic function,
Yeah.
right, you first have to divide this to get it into quartic, and then you have to divide it to get it into cubic, and then you have to divide it to get to x squared. This is the goal. So you have to do long division 3 times. That's why you don't see a lot of quintic questions.
Okay.
You will see a lot of quartic where you have to do long division twice, but not a lot of quintic. So in this question, they gave us the zeros, yeah? They gave us one of the factors, but they don't. Like in a question, they won't give it to you. Like, let's see if we got some examples here. I guess we can do some of these problems. I like doing these, the highlighted ones, because they're usually trickier than the others. All right, so they've given us a volume, and they've given us its length and its width, and we are looking for its height.
Okay.
So how would we do this?
Would we divide it by the length and the height, or the length and the width.
So f of x divided by length times the width, right?
Yeah.
So what do we do here? We just do the long division individually, or what you can do is you can multiply these two.
Oh yeah.
So what does that give you? That gives you x squared plus 5x plus 6. And then you have x3 plus all this guy, and then you do long division from here.
Yeah.
Right, that wasn't that bad, actually. That was pretty
Yeah.
simple. And I hope you know how to do long division. If you don't, it's simple. You just need to practice a couple of times.
Yeah.
Let's do some of these. And these are the factor theorem, remainder theorem questions. The first one, it says there's a cubic polynomial and the p-value is missing. And it says it's divisible by this. There is no remainder. Find the value of p.
Okay.
So what's the goal here? This is the goal. The remainder theorem that says this. If it's divisible by, I mean, it can be in this form as well. If it's divisible by some x minus k, then the remainder, if there's no remainder, then it's f of k is 0.
Okay. Yeah. So would we set it to 0 and then solve for p?
So plug this. No, we don't solve this equation for p, but you see this? Yeah. What's the k value?
-1.
The k is like, I said it here, it's actually,
0.5.
yeah, it's -1/2, right? Minus 0.5.
Yeah.
K is the x-intercept, okay?
Yeah.
So -1/2. So we need to set f of -1/2 equal to 0.
Okay.
Now, how does this work? See, this is f of x.
Yeah.
So we're just going to plug there -1/2. So 8 times -1/2 cubed plus 10 times -1/2 squared minus p times -1/2. Okay? And that's how we solve it. -5 equals 0. What I'm going to do, I'm going to plug this, this, and this in a calculator. So 8 times -0.5 cubed plus 10 times -0.5 squared, and then -5. So I got -8.5 from all the numbers, -8.5, plus this becomes a plus, 1/2 p equals 0, yeah?
Yeah.
Add 8.5 on both sides, multiply by 2, so therefore p is 17.
Oh, okay.
Okay, so you plug this as 0, f of k as 0.
Okay.
The next question is a little bit more dicier because notice the divisor is not linear.
Yeah.
So we cannot use the remainder theorem because that's explicitly only for linear things.
Okay.
So here we are going to have to do this the old school way of long division, and we're going to see what the k value ends up being. So divisor is here, and our dividend is here, minus 2x squared plus k. And again, let's do the long division, and we're going to get a remainder in terms of k, and we're going to set that remainder equals to 5. Okay?
Could you repeat what you said?
Yeah, so we're going to do the long division here, yeah? And we'll get a remainder that will be in terms of k. K plus 14 or whatever, and then we're going to set this equals to 5 to solve for what k is. But here some things are missing. X3 is missing, X5 is missing. So let me rewrite this. X6 plus 0x5 plus x4 plus 0x3 minus 2x squared. Actually, x is missing as well. Plus 0x plus k. There we go. Okay? So what do I multiply this by? What's the first entry up here?
X plus 4.
X.
Or x to the power of 4.
Oh, yeah, exactly. X to the power of 4. Then you get x6 plus 1 times this would be what? Just x4, right? Yeah. And then we subtract it. What do we get?
Well, the x to the power of 6 cancels out. So you would
Oh, actually, there's a little bit of a mistake here. It's not a mistake, but see, even this one, something is missing.
Oh, the x is missing?
Yeah, the x is missing. So you're going to have to take that into account as well. X squared plus 0x plus 1. There we go. This thing
So
doesn't change.
even for the divisor, it has to
Yeah.
be there?
Yeah.
Okay.
See, otherwise that's what we got here, right? We're trying to subtract x4
Yeah.
from x5. We can't really do that. So that's what was missing. So you have x6 plus 0x5, yeah?
Yeah.
0x times x4, 0x5. It's a 0, but plus 1 times this is plus x4. Okay?
Yeah.
We subtracted. This is gone, and this is gone as well.
Yeah.
So
So
now
then
let's,
you do the next one.
yeah.
Right?
So 0x3, yeah?
Mm-hmm.
I mean, we killed 3 of them, right? So we're allowed to bring three more down. So the number that you kill, you bring that many down. Minus
Okay.
2x squared plus 0x. Now let's do this. X2 times what is 0x3? It's just plus, yeah?
Yeah.
0x, right?
Yeah. Okay.
So that's going to give us a 0x3. 0x times 0x is just a 0x squared. 1 times 0x is just a 0. Yeah?
Okay. Yeah.
So we kill this. And then we get, again, this doesn't really change anything. Minus 2x
Wait, why
squared.
isn't the 1 times 0x squared 0x?
1 times this.
Yeah.
Yeah. I just ignored the 0, the x,
Oh,
sorry.
okay.
Yeah. It's just still the 0, right?
Yeah.
So this comes down, and then you have a plus 0x. We only killed 1, and then we finally bring the k down.
Okay.
Again, you don't really have to write this. This is just for this,
Yeah.
just to show the step. And then, because that's arbitrary, right? It doesn't really mean anything. And then finally, x2 times minus 2, right? Minus 2 is minus 2x squared. So minus 2x squared. 0x times minus 2 is minus 2x. Plus 1 times minus 2 is minus 2. Yeah?
But is it the 0x times -2? It wouldn't be 0x?
That's right. Yes, that's actually right. So that would be minus 0x. Yeah, you're right. Minus 0x and then plus 1 times minus 2 is minus 2. Yeah, there we go. So when you subtract them, this cancels out, yeah? This
Yeah.
becomes a k plus 2. So your remainder is k plus 2, and we know that is equals to 5. So therefore, k is 3.
Okay.
All right, a little tricky, this one.
Yeah.
Yeah, so even when the divisor has missing things, you have to add a 0 there.
Okay.
And let's move on to the next part, factoring polynomials.
Okay.
Alrighty, let's do this one. And we're also going to graph it, and you're going to see how to do this. So now notice here, they have not given us any factors or nothing like that.
Yeah.
So what do we do here?
Well, we have to get it to a quadratic, right?
Yes, so we're going to have to divide it by a linear, right? So
Yeah.
how do we get that linear guy? So you have to write down the factors of 24.
Okay.
This one's going to be painful because there's a lot of them. Oh my God. Yeah, that's a lot. There's 16 to check.
Okay.
So this is going to be f of x, okay? This is f of x. So we're going to start off by plugging f of 1. Well, 1 in there will never give you a 0 because it's not big enough to kill positive 24. So just by intuition, I'm not even going to bother checking that.
Okay.
Because yeah, you need to, all this needs to be add up to minus 24, so that's not big enough. Same thing with the -1. That's not big enough to make a minus 24 here, yeah?
Yeah.
So we can just move on to positive 2. So f of positive 2, again, this is very tedious. So that's going to be 8 minus 20 minus 4 plus 24. Does that work? No, that does not work. 24 plus 8 is 32. That's just 24. Let me try f of minus 2. That'll be minus 8 minus 20 plus 4 plus 24. F of minus 2 works.
Okay.
Yeah, you see how I did this? I just plugged
Mm-hmm.
minus 2 in there and just plug that in the calculator or whatever. So what does that mean? If f of minus 2 is a 0, then what's our factor?
X plus 2.
Good. X plus 2 is a factor, right?
Yeah.
Is a factor.
So you have to keep. Do you still keep going through all
No, you
of
don't.
them?
You just need to find one.
Okay.
Just find one and you're good to go. If your teacher's mean, you're gonna have to keep going like till like here until you get the first zero. But that's rare. That doesn't really happen. Actually, you've heard of the A-level program? I think you have.
No.
A-levels. It's like a British high school system. What of the gifted class? You've heard of that?
Yeah. Yeah. I've heard of the difference. Yeah.
So that one's they're very like mean in this.
Okay.
Instead of just looking for the whole number divisors, right, or factors of
Uh-huh.
this, you also have to check for these guys.
Oh.
Plus 0.75 goes into this, 0.5 goes into this, 2.5
Yeah.
goes into that, right?
Yeah.
So it's a lot more tedious.
Yeah.
But not here, though. Here you just look for whole numbers. Even that could
Yeah.
be tedious. But anyways, so here we have the first factor. Again, we're going to use synthetic. What's our k value?
-2.
-2. Anything missing here? Nothing missing. So coefficient is 1, -5, -2, 24. This drops down, -2, -7. Again, you add in synthetic, you subtract in long division. +14 -12. Actually, did I mess something up here? This should have been a 0. 1 times 2 minus 2, positive this. Oh, this should have been a positive 12, my bad. 14 plus -2 is a positive 12, times -2 is -24, and you get a remainder of 0. See, if this works out, that means you should get a remainder of 0 using the remainder theorem, right?
Okay.
So what's our quadratic here? Our quadratic is this guy. So we started off with a cube. So what's going to be this quotient? It is 1x squared minus 7x plus 12.
Yeah.
You agree with this?
Yes.
Okay, so therefore I'm gonna rewrite f of x, right? I'm gonna rewrite f of x. And if you're confused about this, just check this out. This is our f of x, okay? Our
Yeah.
dividend is f of x. That is equals to the quotient times the divisor, right? Which was x plus 2.
Yeah. Yeah.
And we can factor this, again, using the man method, two numbers that multiplies to 12 and adds up to -7. Does it exist? 3 and 4, -3, -4. Yeah, it does exist. So this factors out to x minus 3, x minus 4, okay? The quadratic using the man method, and times x plus 2. There you go. This is the factored form of this cubic equation.
And then you can graph it too.
Yes, we can graph it very easily.
Yeah.
So here's something I want to talk about in the graph. So it's plus 24. Again, this is just arbitrary. That's my y-intercept, and our zeros are 3, 4, and -2, right?
Yeah.
Just the x-intercepts from these. So 3, 4, and -2. So we can just connect the dots, right? We can just connect the dots. We know this is a positive cubic function. So it's gonna start here and it's gonna end up there, right?
Yeah. Yeah.
So it could look like this. Okay, that'll be the answer to this question. But what I wanted to say was that if you want to graph this, in this course, there's an infinite number of answers. Now, what do I mean by that? See, when we just connected the dots, we could have also done this. Instead of going this and this, I could have done this. See, the turning point is all the way up there.
Yeah.
And then the turning point is all the way down there. And then it goes again. So we don't know where these turning points are in this course. So you don't have to worry about it. You'll worry about them in this one.
In calculus?
Yeah, you have to find out precisely where they turn. See, it's gonna be more precise in that course. But here, you don't have to worry about it. There's an infinite number of answers here. Okay, you can even drag this less and whatever. Okay.
Would you ever have, like, even in factored form, any of them to, like, squared or to cube?
Yes, they could be. Yes, good question. So let's say you have some f of x, and that is like, let's say x minus 2 squared, x minus 3 cubed, and then x minus 4. Okay. Actually, I'm just gonna make this into x plus 4. Yeah.
I noticed that, like, the square means it's a turning point, so you it has to, like, go in like an increasing or decreasing interval, and the cubed is an inflection point, and the linear is just a pass through.
Yeah, that's
But, like,
right.
how would you get to that?
Oh,
Like
when you factor them out, like it'll work out nicely. This is we have overshot this. So you only do up until x5 here. So let me get rid of this. Actually, for the sake of this, I'm just going to keep it there. So this is an x6 polynomial. The degree of f of x is x6. It's
yeah,
positive, right? The leading coefficient is
yeah,
positive. So we start there, we'll end there, okay?
mm-hmm, yeah,
And the y-intercept is whatever. Let's say the y-intercept is down there. So our zeros are at +2, +3, and -4, right?
mm-hmm, yeah,
So see, this is a linear. That means when you look at when you look at -4, there's a linear function that's passing through it, like a straight line.
yeah,
So I'm just gonna connect these dots. It's gonna go through the y-intercept, and at 2, see, this is called the order. The order of this factor is 2. So when you have an order 2 factor, that means it's a turning point.
yeah,
So at this point, it's gonna turn upside, like it's gonna be a negative parabola like that, okay?
yeah,
And this one, the order of this factor is 3. So order of factor 3 means it's gonna act as a cubic function there, or there
mm-hmm,
it's a point of inflection. So something
yeah,
like that. Okay,
mm-hmm.
and that's all there is to it.
But when you you know how when we factored them, they always ended up, even when we did one with like 6 or 5, like a quintic or anything, they always ended up to like at a linear, like when they're fully factored. So, like, how would you end up with like a squared or a cube?
So let's see. It'll just work out nicely. Like for example, you could get something like this, right? You could get, let's say this one, x squared plus 6x plus 9 times x plus 2 or whatever, x minus 1, let's say this one. So when you open this, you'd get a cubic function, yeah?
Yeah.
Actually, we can just open it. It's going to take like 2 seconds, minus 6 squared. What am I doing? I'm going this way. Okay. So plus 6x squared minus 6x plus 9x minus 9. Just put up the like terms together. You get something like this. Okay. See, this is a cubic function.
Yeah.
So for this one, how do you factor this, right? You're going to check for the factors, right?
Mm-hmm.
So it's only plus minus 9 and plus minus 1. And turns out f of 1 is going to work out, yeah?
Yeah.
F of 1 is going to work out. So when you do the long division, right? When you do the long division, you're going to get a quotient of this, x squared plus 6x plus 9. Okay. Now, when you go to
Yeah.
factor this, you're going to get x plus 3 times x plus 3, because two numbers that multiplies to 9 and adds up to 6 is 3 and 3.
Yeah.
And see, there we go. You get a degree 2 factor.
Oh, okay.
Yeah,
Okay,
so the
that makes
quadratic, you're going to end up, yeah, with like a perfect square. Same thing with the
okay.
cubic. It could be, yeah, it could have 3 cubes, but the idea is the same.
Okay, that makes sense. Okay.
Yeah, once you know that, I mean, you should be able to do the rest of them, right? See this one? What's the degree of this polynomial or this factor here?
Uh, 4.
Yeah, f of x is 4. Yeah, what's the order of this factor? That's what I was trying to ask you.
Oh. Mm, would it be 2?
No, it's gonna be 2 if the squared was on the outside.
So then I don't know what it
It's
would
it's
be.
it's it's 2 if it was outside, okay?
Okay.
So that it would have been a turning point if it's on the outside. So that means this is not a turning point, as it
So
is.
it's just passing through
Yeah,
then?
exactly. In fact, this one, it's not even gonna work out because you'll be taking the square root of -2. Right?
Okay.
When you go to find the x-intercept, you'd be
Yeah.
taking the square root of -2. So that one's not going to work out, but it's going to be a turning point only if it's outside.
Okay.
All right, here, let's try this one. Again, this is using the factor and the remainder theorem. So we have two unknowns, m and n. When this is divided by this is the remainder. And when that's divided by something, x minus 2 is a factor, determine the values of m and n.
Okay. Would you use the no. Oh, could you use the remainder theorem?
Yes, you could. Yes. So what do I do? So we're going to call this f of x.
Okay. And then you would plug it in. You would plug in -1, right?
Yeah. So
And
what would that be equals to?
0. Or it should be equal to 0.
No, it won't be equal to 0. When it's divided by this, the remainder is minus 12.
Oh yeah. So it won't be.
Minus 12. But when you plug it in positive 2, right? Case 2 there, what would that be
Yeah.
equals to?
That would be 0.
Yeah, exactly. There you go. You're going to solve these two. You're going to get two linear equations. So we can just do this. That's going to be 2 times -1 cubed. That's just -1. Minus m times -1 squared is just m. Minus n minus 2 equals minus 12, right?
Yeah.
And then this is -2 minus 2. That's going to add up to -4. So you have minus m minus n is equals to minus 12 plus 4. This is just basic linear here. Minus m minus n equals -8. Multiply everything by -1. M plus n equals 8. And m is 8 minus n. And we're going to get another equation out of this. So that's going to be 2 times 8, 16 minus 4m plus 2n minus 2 equals 0. So this means minus 4m plus 2n equals 2 minus 16, -14. And you can just plug this in here as m. Minus 4 times 8 minus n. Yeah?
Yeah.
Are you following this? This is just substitution elimination.
Yeah. Okay.
And once you have the n value, you can plug it in there to find the m value. Yeah, I'm just rushing through this because this is pretty simple stuff.
Yeah.
N is 3, so that means m is 5, and you're done.
Okay.
But the main idea here is this line and this line, the new stuff. Once you get those, then it should be pretty straightforward from there onwards.
Okay.
What do you do next? Factoring a sum's difference of cubes. This is very simple as well. You just need to follow a formula. Here, let me do one question, and then I'm going to have to let you go, unfortunately.
Okay.
So up until grade 11, we did a difference of squares, right?
Yeah.
Now we're going to do difference of cubes. Now, how does that work? Here, let's look at this. If you have x cubed minus 8, yeah?
Yeah.
It's in this form. What's your a and what's your b?
2.
Yeah, b is 2. What's your a? A is just x, right?
Okay.
A cubed is x cubed, and so that means a is x. B cubed is 8, that means b is 2.
Okay.
So the answer to this in factored form, you can just factor this straight up. That's going to be x minus 2, a minus b. Yeah?
Okay.
X squared is ax squared plus ab is 2x plus 4. There we go. We factored it.
Oh, okay.
Let's try something a little bit more difficult. 27 x9 minus 64 y27.
Oh, okay.
What is a? What is b?
Would it be 3
Yeah, 3 something.
and 2?
So a cubed is 27x9, right?
Yeah.
So a is the cube root of this, right? The cube root of 27 is 3. The cube root of x9 is what? What's the cube root of x9? x3.
3. Okay.
Same thing, the cube root of y27 is y9. Okay?
Okay.
And there we go. Once you have your a and b, you just plug it into this formula. There it's just simple from there onwards.
Okay.
And that's the last thing in this unit.
Okay.
Cool?
Okay.
Alrighty, I'll upload this when I have time. Probably in the next hour or so.
Okay. No problem. Thank you.
All right, I'll see you when I see you next.